Hi there, it's Professor Smith, and thanks for stopping by to watch my video. I know there are a ton of normal distribution videos on YouTube, but none of them are mine, so I thought I would make my own for you. Happy Memorial Day. Well, it's almost over, but hope y'all had a great holiday weekend. I took this image from your author's PowerPoints to talk about the shaded area to the left of Z or to the right of Z or in between two Z-scores. Remember, Z is our standard normal random variable with a mean of 0 and a standard deviation of 1. So I have a few examples to go over with you. First one I have here is the area under the curve to the left of a given z-score, and I also have the area under the curve to the right. And actually, the area under the curve to the right is the image that I borrowed from McGraw-Hill, and I rotated it or flipped it horizontally, and that's why over here the 1.11 is backwards. Technically, that should be negative 1.11. So to find the area under the curve to the left of, oh, I got some typos here, z equals 1.11, I will have to consult my normal table. And so if I'm looking at negative 1.11, I want to look at the negative side of my table. And I'm going to go down in the rightmost column. This isn't working as well as I thought. In the rightmost column to negative 1.1. So I'm going to hold that place. And then in the top row, I also want to go to 0.01. And you can see the place that this row and column intersects is at 0.1335. So our area under the curve to the left of z equals negative 1.11 is, as we found, 0.1335. So let me fill that in. Now I have that this is equivalent to the probability that z is greater than 1.11 on this graph on the right that I already explained. So if you can see this horizontal rotation from the area under the curve to the right of 1.11 transforming to equal the area under the curve to the left of 1.11, that'll help you easily identify areas under the curve to the right without having to subtract from 1. Okay, let me do a quick save. And now we'll look at the area under the curve in between two z-scores and outside as well. But I'm going to start with the area under the curve in between negative 2.48 and negative 0.83. So again, I borrowed a McGraw-Hill picture, and I have the area under the curve that I am looking for denoted with the shading. And I have the little hints that I gave you in class to take the big area minus the little area to get the area in between, which is the answer. So the bigger area is going to be the area to the left of the larger of the two z-scores. So consulting my table for to the left of negative 0.83, I'm going to have to move my column to negative 0.8 and over to 0.03. And now my intersection is going to occur at 0.2033. So the area under the curve to the left of the bigger one is 0.2033. And the area under the curve to the left of the smaller of the two z-scores, negative 2.48. Again, I go to my table, I go to my row of negative 2.4 and my column of 0.08, and those intersect at 0.0066. 0.0066. So I fill that into my subtraction. And so the difference of 2033 minus 0066 is is 0.1967. You can pause and confirm if you would like. And I'm going to move on to area under the curve on the outside of two z-scores. So now in this previous example, you could see z in between two given numeric values. In this case, they're saying z is less than some number or greater than some number. Recall that or in a probability statement means you need to add. So the first piece of information that we need is the area under the curve to the left of negative 3.01. So I'm going to go to row negative 3.0 and the column of 0.01, and the intersection of those two looks like 0013. So the first area under the curve that I'm going to plug in is 0.0013. And I need to add to that the area under the curve to the right of 2.43. But remember the flip transformation that we made in the first example, where we took the area under the curve to the right of a positive is equal to area under the curve to the left of a negative. I'm going to use that same idea here to find the area under the curve to the left of negative 243. So in my normal table, I'm going to go to row negative 2.4 and the column of 0.03, and those intersect at 0.0075. So the area under the curve to the left of negative 243 is equal to the area under the curve to the right of positive 2.43. And I need to add these two together to get 0.0088. Oh. Just want it to fit nicely in there. Okay, moving on, we will now find a z-score given an area under the curve. So my editing got changed in this document, so let me just tweak a little bit here. Okay, so we have to find the area, nope, not the area, the z-score, such that the area under the curve between 0 and z, some negative value, is 0.4738. Well, that doesn't help us very much because our table doesn't give us the area in between 0 and z-scores. It gives us the area under the curve to the left, although tables that look like this do exist. So we're going to use the property that the mean of 0 cuts the distribution in half. So that means the entire area under the curve to the left of 0 is 0.5. And if we take the shaded area, 0.4738 from 0.5, that'll give us this unshaded area here, which is 0.0262. Now that we have the 4-digit number that we can locate in our table, we will go to our table. And now we're going to try to find 0.0262. There it is. And we are going to follow that out left and up for an intersection of negative 1.94. So Z is negative 1.94. It doesn't be there twice. Okay. Here are a couple more examples of finding Z. Now, the answer to both of these questions is going to have the same absolute value, just different signs. So in this picture, I have the area under the curve to the right. Maybe I should flip these, huh? It's not going to let me right now. To the right of some positive z-scores, 0.0239. Well, as you see, I rotated this image horizontally, and now I have the area under the curve to the left of some negative z-score is 0.0239 as well. So, going to the table, reminds me of something else, 0.0239, up there she is. And I'm going to need to follow that 4-digit number left to negative 1.9 rows still, and up to 0.08 column. So those intersect at negative 1.98. So over here, we have negative 1.98. I need a bigger answer box. And over here, then, therefore, will be positive 1.98, again, requiring a bigger answer blank. So there you have it, areas under the curve to the left, to the right, in between, outside a given or given z-scores, and finding the z-score with a given area under the curve. Oh, look at that. I've got one more example here. So this question is asking for the area under the curve to the right of some negative z-score, which horizontally flipping gives us to the left of some positive z-score. So I could find this 8962 without having to do any math at all. Just going to go to the positive side of my table. I'm going to take my highlighted box and I'm going to look for 8962. There it is. And so I follow out this row. And I need the column as well. And they intersect at positive 1.26. So going back to my problem, if this is my picture, then my z-score is 1.26. If this is my picture, my z-score, I'm going to beat you to it, is negative 1.26. And I have one more example that's already worked out for you. You're just going to have to draw the picture. This is from Mike Sullivan's 5th edition. He asks to find the area under the standard normal curve between z is negative 1.02 and 2.94. So hopefully you could draw a picture, maybe take a quick pause and shade between those two z-scores. And he just gives us the words. The area in between these two z-scores is equal to the big area minus the little area, as I said in class. So to the left of 2.94, you could confirm these on your table, and to the left of negative 1.02, again, you can confirm these for a result of 0.8445. Thanks for checking out my channel, and